Okay, so in this particular case, what we've got is hydrated copper sulfate, right? And the mass of the hydrated sample has been determined as 8.39 grams. And when the water's been removed, the mass has been determined as 5.15 grams. Okay. Now, before I continue, one of the things I'm just going to mention, and you may have seen it in the disclaimer, is that this example, a number of the examples in this series, they're mainly provided as a mathematical exercise, as a tool for really developing confidence with your calculations, as opposed to necessarily reflecting what might be a plausible or likely value for the actual coefficient in a what you might find occurring experimentally in terms of waters of crystallization. Because some of the values which you might find may seem a bit unusual on a chemical level, but this is primarily like almost like a mathematical training exercise within a hypothetical chemical context, mainly to build that mathematical skill, which is generally important for. Anyway, let me not go on about that. So in this particular case, what do we need to actually do? Well, the anhydrous mass we've been given is 5.15 grams, right? And the real question we're trying to answer here is, well, for every 1 mole of copper sulfate, how many moles of H2O are we going to get in the hydrated sample? Now, it's better to try to really make these comparisons within a context of amounts of substance, right? So in terms of moles, but whereas what we have here are masses. So one of the first steps I'm going to take is converting some of the relevant values into a molar context rather than this kind of mass context, right? So and what am I going to use to facilitate that? Well, I'm going to be using the equation that the number of moles N is equal to the mass M divided by the molar mass MR, okay? And so the first thing I'm going to focus on within a context of that is the CuSO₄. So for CuSO₄, the number of moles N, right, of CuSO₄ is going to be the mass, right? So the mass M, 5.15 divided by the molar mass MR. So now, the value of MR has not yet been worked out for CuSO₄, so I'm going to go ahead and do that, right? So you've got a few excerpts of the periodic table here. So relevant would be copper, sulfur, oxygen, right? So, and I've got these here as well just for convenience. So so what we can say is the molar mass MR for CuSO₄ is what is going to be 63.5 plus, so that's for copper. Sulfur's relative atomic mass 32.1 plus, and then this is O4, so we're going to do 4 times the relative atomic mass of oxygen, so 4 times 16, right? And so that's going to give us the molar mass of copper sulfate, which comes to 159.6, right? And that's going to be in grams per mole. Okay, right. Now, one of the things we're going to look at here is, okay, let's just sort this out first. So 159.6, right? So if you work that out, let's see what that comes to. So that's going to give you 0.032268, right? And that's going to be in moles, right? So that's basically to 5 significant figures. But now that we've got that, we also are going to look into, well, what's going to be the number of moles for the H2O? So how could we work out the number of moles for the H2O? Well, we're going to need the mass of the H2O first, right? So, but to get the mass, we've got values of the hydrated copper sulfate, the anhydrous copper sulfate. Well, we can use arithmetic to work out the H2O mass. So, because this is the mass without the H2O. This is the mass with. So, simply you can just do the mass with minus the mass without, and then what's left is the H2O, right? So that's effectively 8.39 minus 5.15, right? And that's going to give you 3.24 grams. And this relates to the mass of H2O, okay? Now that we've got that, we're also going to need the molar mass of H2O to kind of progress this, because we're doing mass divided by the molar mass, right? So if we refer back to the periodic table again, for the mass of H2O, that is effectively 1 times 2, so wait, molar mass, so molar mass, I meant molar mass of H2O, that's going to be effectively, so for hydrogen, it's going to be 1 times 2, right? So because it's H2, plus the relative atomic mass for the oxygen, which is 16, right? And that's going to give you 18 grams per mole, right? And so in the context of H2O, when we're looking at the number of moles for H2O and for H2O, that's effectively going to be 3.24, right, divided by 18, okay? And so if you work that out, this is going to give you what the number of moles corresponding to the H2O is, and that's going to give you 0.18, okay? 0.18. Okay, so what we have, and that's going to be in moles. So what we have now is we've got molar value for the copper sulfate, we've got molar value for the H2O. What you notice here is that really, as I said, kind of the question we're really asking is, for every 1 mole of CuSO₄, how many moles of H2O are going to be present in this hydrated sample? Now, one of the steps to move towards getting closer to that answer is to compare these two molar values, right? And so we can set up that comparison. Because CuSO₄ is on the left in this, I am going to put it on the left in the what you're going to see below. But in effect, you're going to have the number of moles of CuSO₄ compared to the number of moles of H2O, right? And for CuSO₄, we're going to have, this is effectively going to be this value here, so it's going to be 0.032268, right? And that is going to be, for the H2O, it's going to be 0.18, right? Yep. Okay, so once again, the real question we're looking at is, for every 1 mole of CuSO₄, how many moles of H2O? And we're looking for an integer value. But in order to progress in that direction further, what we really want to do with these molar values is get at least the one relating to the CuSO₄ to be a value of 1, right? And what's the fastest way to do that? If we've got a value, how can we get it to 1? Well, if we divide it by itself, we're going to get to 1, right? So in this case, if we divide this by 1, we are going to get well, no, not divide by, I think I just said divide by 1. Not if we divide by, but if we divide it by itself, we're going to get to 1. Yeah, so not divide by 1. So divided by, if we divide it by 0.032268, then of course the answer is going to be 1, right? Because we've divided a number by itself. And because we've done that to the left hand side, we do also need to do that to the right hand side. So we also need to divide this by 0.032268, okay? And if you have a go at working out what value that's actually going to be, what you should find is that you're going to get 5.5783, okay? And what I'm going to want to do at this stage is say, well, we're looking for an integer value, and so what I'm going to do is I'm going to round this number to the nearest integer value, right? So if we're trying to round 5.5783, we are going to have to round that up, and if we round it up, it's going to be approximately 6, right? So what I'm going to do is, this is going to be a case where the 1, for every 1 mole of CuSO₄, once we've done that rounding, our conclusion is that, well, you're going to get approximately 6 moles of H2O, right? And on that basis, we're going to say, well, therefore X is equal to 6, okay? And therefore the formula, right, the hydrated formula is CuSO₄, right, dot, and then 6 H2O, right? As to say, for every 1 mole of CuSO₄, we're going to get 6 moles of H2O, approximately. And so up here, where we've got the space to kind of enter a number in the formula, we can put a 6 here, right? Okay,